In this video, we are going to look at the matrix equation or simultaneous equation using matrices. So we are solving simultaneous equation using matrix method. So from these two equations, 7x minus y equals 15, 3x minus 2y equals 19, we first start by forming what we call matrix equation. So when you're forming a matrix equation, you need to have this type. So what we put here are the variables, which is x and y. Then what we put this side are solutions, which is 15, 19. Then what we put here are coefficients. We start with the first coefficient is 7 and 3. And then the second coefficient, it is we get anything behind y, anything behind y. So here we can see that there is the negative, meaning -1. Then this is -2. So from there, name this matrix. So you say let M or any letter of your choice become that matrix. Why am I doing this? Because I need an inverse to multiply to both sides of the equation. I need an inverse to multiply to this side of the equation and to this side. This is why I'm doing this. So it's now my time to find the inverse of this matrix. The formula for the inverse of a matrix is as follows. So the inverse of a matrix is given by 1 over determinant of the matrix times adjoint of the matrix. Determinant of the matrix, you go to your original matrix, multiply this leading diagonal always first. It will never change. It is always this one. So it is 7 times -2, which will give you -14. So 7 times -2 will give you -14. Then always put a minus, always. This one, which is 3 times -1, this is the second to be multiplied. Always start with this one, and then minus is a must, and then multiply this. This and this, which is 3 and -1, 3 and -1, the answer is -3. But because there is a negative already, that's when you change this guy to a plus. So you only do that if your answer after multiplying the minor diagonal is a negative. That's when you change this guy to a positive. But if your answer comes out to be positive, you will just maintain that answer without changing the minus that was there. Thereafter, if you combine this -14 and 3, you expect to get -11 as your answer for the determinant. Next thing, in the inverse formula, there is 1 over determinant, and you have found the determinant. You need to find the adjoint. So the adjoint of this matrix, M, it's not difficult. The leading diagonal, the one you multiply first when finding the determinant, is to be swapped. So where there is 7, put -2, and where there is -2, put 7. So that's what we're going to do. Then the other diagonal which you multiply second when finding the determinant, make sure you multiply each element with a negative. So 3 times -1, it will become -3. So that's what happens. It will become -3. Then the other element also multiplied by a negative, it will change to a positive. Thereafter, you will say the inverse of this matrix now becomes 1 over -11, and the adjoint, just get it the way it is, don't do anything. So this is the inverse of a matrix. So that inverse of a matrix will now be multiplied on this side of the equation and on the other side. So that is what we have to do next. So this inverse will be multiplied on both sides. Okay. we get the inverse, which is 1 over negative 11, row 1, negative 2, 1, row 2, negative 3, 7. And then we are multiplying it by the original matrix, which is the same inverse should be multiplied on the other side. The same inverse should be multiplied on the other side. So this side we are getting now the solutions. Okay, it's now time to multiply. So when you're multiplying, it's row by column, row by column. So we're going to say the first entry in a row with the first entry in a column. So we're going to have negative 2 times 7. First entry in a row with the first entry in the column. First entry in the row with the first entry in the column. So negative 2 times 7 will get negative 14. And then 1 times 3 we get a 3. We're done with the first row and the first column. So if you move to the other column, you also move. So it is now negative 2 times negative 1, which is a 2. So first entry in a row, first entry in a column. Second entry in a row, second entry in a column. Third entry in a row with a third entry in a column, just like that. So 1 times negative 2, we're going to get negative 2. We are done for this part. What follows is x and y. We are now here. First entry in a row with the first entry in a column. So negative 3 times 7 will get negative 21. Negative 3 times 7 we have gotten negative 1. 3 times 7 will get a 21. We move to the other column. First entry in a row with the first entry in a column. Second entry in a row with the second entry in a column. So negative 3 times negative 1 will get a 3. Then 7 times negative 2 will get negative 14. Like that. Then we move to the other side. We have got 1 over negative 11. It's now first entry in a row with the first entry in a column. First entry is negative 2 times 15. We're going to get negative 30. Plus, so first entry, this and this, which is negative 2 and 15. Then 1 and 19. We're going to get 19. We do not have another column. Hence, we cannot move to the other side, but we just close the matrix. Then we come here. This is looking like 37. Negative 3 times 15. Negative 3 times 15, which is negative 45, which is 45. Plus, then we have got 19 7 times 19. Remember, first entry in a row we multiply with the first entry in a column. So the first entry was negative 3. It has multiplied with 15. It's now 7 and 19. So 7 times 19. We have got 7 times 9. That is 63. We write 6. We write 3, carry 6. This is 7 and 1. It is 7 plus 6. That's a 13. So we're going to have 133 there. So this is what we have at the moment. This is what we have. Okay, so from here we now need to simplify what is inside So we're going to have 1 over negative 11. Then we just start simplifying. So negative 14 plus 3, we are getting negative 11. Negative 21 plus 21. Remember, whenever the same number is being added but the signs are different, the answer is a 0. Same number being added but the signs are different, the answer is 0. 3 minus 14. 3 minus 14 is negative 11. Then we are remaining with this part. Then here we have this one from this side. We combine inside. Here we are dealing with negative 30 plus 19. Negative 30 plus 19. The answer there it's negative 11. Then we have 45. We have 45 plus negative 45 plus 133. So it's the same one saying 133 minus 45. But get your answer to be, yeah, that's what we're dealing with. So 5 from 3 it can't, you get 2 from there, you add there. 5 from 13, that's 8. Then it's a 12 minus 4, which is 8. Hence our answer is 88. So just to bring this lower part on top here, what do we have now? So this is 1 over negative 11. So what will happen is this number which is down shall divide every number inside there. So 1 will multiply and then you divide. 1 will multiply and then you divide. So whenever there is a scalar outside the matrix, it means that it has to multiply every element inside individually. So that's what is going to happen. So it's 1 times negative 11. The answer is negative 11 divided by negative 11. The answer becomes 1. Any number times 0, the answer is 0. Any number times 0, the answer is 0. Then what happened here is what is happening here. So the answer for this part is the same answer for this part. Hence we're getting a 1. We're here. 1 times negative 11 is negative 11 divided by negative 11. The answer is 1. Then 1 times 88, the answer is 88. Then how many 11s are in 88? The answer is 8, but there is a negative, so we get negative 8. What we have here is a basic principle of a matrix. This, when we have leading diagonal having 1s and everywhere else 0s, we call that an identity matrix. So an identity matrix is represented by letter I. So identity matrix times any matrix, the answer is any matrix. So using this rule, when you have got an identity matrix and you multiply with any matrix of your choice, then the answer is still the same matrix. So in this case, we are going to maintain our answer as x, y equals 1, negative 8. With that said, we can conclude to say the top number is this one and the bottom number is this one. So x equals 1 and y, x equals 1. X equals 1 when y equals negative 8. So this is where we end. So the values of our equation, of the values of our variables in the equation, x equals 1 and y equals negative 8. So thank you very much for watching up to this end. Thank you very much.